All right. Hi, everybody. For anybody who doesn't know me, my name is Brian McCullough. I'm the meeting chair for the Royal Astronomical Society Ottawa Centre here. Running the PowerPoint program for us tonight, Chris Tarrant, just off to my right here. Now that everybody knows my name, Brian, I'll take one thing off my neck. I've got too many things hanging around my neck here. All right. A couple of interesting things on the go. We've got a couple of news items, a couple of interesting little talks for you. And now the Frasers aren't here tonight. They normally have the coffee and drinks in the back. But I brought some drinks down and some cookies. There's no coffee. And Linda Myers graciously acquiesced to my request to woman the booth, as it were. All right? All right. In case you didn't know, it's August 1st. Here we go. Breaking news. All right, ready to roll? Has anybody seen this already? Has everybody seen this? Now, it's just interesting. I'm in the middle of an intensive 5-week French course, and I just did a presentation yesterday for my oral communication class. And what did I do it on? Is there life elsewhere in the universe? And I talked specifically about the Phoenix mission on Mars, and also about the possibility of the seeds of life possibly could be found in the methane lakes on the moon Titan of Saturn. But anyway, the Phoenix spacecraft on Mars, of course, had detected some ice just under its foot. And of course, people have been thinking that it probably was water ice, but they wanted to get it into its little easy bake oven so they could test it and be 100% sure that it was in fact water ice. Now, they've known for about 6 years that there is probably water ice on the surface of Mars, and it was it yesterday or the day before? Day before yesterday. They had trouble. The Phoenix lander has a little scoop on it, and it's like a kid's toy, and just scoops up some dirt and pulls it into an oven, and they heat it up, and they can examine the gases coming off to see what the contents of the sample are. Unfortunately, with the ice mixed into it, everything got clogged up, so it took them a little while to let things dry out a little bit, let some of the water evaporate before they could test it in the oven. And lo and behold, there it is. They've identified water on Mars. So where they have been examining the surface of Mars and seeing the features where it certainly looked like water runoff from river systems, well, this is, I think we all know what the answer is for certain now. All right?
The 3D image we were looking at, was that the scoop?
Oh, that's right. Now the 3D image that we had up on the screen there a few minutes ago. Yes, that was one of the scrapings left behind from the little scooper. Yes.
The lander has 4 of those ovens. Right?
Yeah.
The lander has 4 ovens. That's right.
And it's used 2 so far?
I think it's just used 2 because it can only use the ovens one time, because obviously they become contaminated. Okay, let's go to the next one.
More here.
Oh.
Well, I'm very happy to announce that we've gotten an ice sample into the Tiga ovens. When we first found this out yesterday, we were really pleased. There were champagne corks popping in the downlink room, and we just had a great time of it. It's something we've been waiting quite a while for. Of course, we know the GRS on Mars Odyssey discovered this ice 6 years ago, but we've now finally touched it and tasted it. That's one thing that hasn't been done before. And I'd like to say, from my standpoint, it tastes very fine. I'm very glad to be in this position.
Awesome.
Through this analysis, we also hope to be able to answer a question that goes beyond just finding water ice, but is this a habitable zone on Mars? A habitable zone meaning that we have periodic liquid water, not today, but over time, and we have the materials that are the basic ingredients for life forms. It'll be for a future mission to find if anybody's home in this environment, but we'll be finding that this is a place that needs to be searched for life forms throughout the next 2 months of our approved mission.
And another thing too, the mission's been extended.
Oh, and that's the other aspect. The mission's been extended. What's the date of? Do you remember?
It's extended into September.
September.
Another 30 to 60 days, if I recall.
So another 30 to 60 days on the mission. So another phenomenally successful mission there. All right, let's hit the next one. Here we go. This is now we're looking at the surface of the moon Titan in the Saturn system, the Saturnian system, and when the Huygens lander left the Cassini spacecraft and landed on the surface of Titan, what's that, 2 years ago now? Something like that. I have no concept of time. They detected what they figured were lakes of methane. And sure enough, now at the same time, they're confirming that the lakes are in fact pools of liquid methane. So, of course, methane is you could call it one of the primordial ingredients for our life system. So I figure if they tap deep enough into those lakes, they're going to find some creepy little crawly thing that's going to be just fantastic. So, all right, let's go to the next one, please.
High hopes.
Okay, Tim. Tim will give us an idea of what's coming up in the skies for us this month.
Stars, another 39 days of cloud.
Thank you.
See, it's not so.
It's not so. I lied. Okay, we've got a shadow transit of Io coming up at a really nice time on Hiroshima Day, actually. I really shouldn't have. Very bad taste. Which is kind of, anyway, never mind. If any of you haven't had a chance to see a shadow transit of Jupiter, Jupiter's nice. Well, it's not beautifully placed for it because it's still a bit low in the sky, as the Finder chart there will show you, but a shadow transit's a lot of fun to watch, and this one's at a sensible hour, so if we can roll the animation of it, this will give you a sense of what we're looking at. Now, one of the fun parts with an Io shadow transit is that Io moves so fast. I forget its orbit, but it's under 2 days. And it moves so fast that you can watch the whole transit in a reasonable period of time. So what we can see here, we've got, if I can ever find a switch on this.
On the
There
flat
we go.
side.
There we go. There's Io just going off the moon, and there's its shadow being cast on the moon as well. And then as a freebie, you've got the great red spot showing up as well at the end of it all. So
Maybe we can run that a second time.
yeah, why don't we try that? So this is about 30 times normal. My mistake, slipped to 0, 300 times normal speed. But if you watch these with Io, it is quite noticeable, and it actually is quite enjoyable to watch. And the nice part, too, is you can come back after an hour and really notice the difference.
And can we show that a third time? And you'll see just at the 2 o'clock position, you'll see one of the other moons is just slipping behind Jupiter.
Right,
We'll
good
run that
point.
one more time, please. Thanks.
Wants to finish.
Oh, wants to finish. Okay.
Well, prima donnas. He's ready for its
See
close-up.
the
Yeah,
moon?
oh yeah, right. I forget which one this is. It might be Europa, but I can't recall for sure. Again, these things can be looked up. You don't have to cheat. Actually, looking up does help you cheat, but that's another story too. So anyway, good fun. You don't need a super huge telescope for this, but certainly, I mean, binoculars won't cut it, and a little 4-inch, you might find it kind of tough unless the conditions are perfect. A nice big daub will do nicely, but anyway, some good fun to be had with this one. So, now we have, oh, good, you're making me not have to lie here. This is just another one of those lovely little Kodak moments. A whole bunch of planets in the evening sky. Venus will be the biggie. Saturn. In fact, those are backwards.
That's right.
Somebody changed my picture afterwards. Yes, ungrateful persons.
Can Chris and I slip out now?
Yes. Well, I stopped them because they were going to use the old picture that didn't have Mars, and they were just going to put the arrow up anyway, thus forcing me to lie, and I was not going to be happy, which they really didn't care about, but at any rate. So anyway, one of the nice things with this is it's a crack at Mercury, which is, you know, reputation has Mercury to be incredibly hard to find, which is a complete load of rubbish. It's not. But it is a little tricky because it's never very high. So it's nice if you have a signpost nearby. And Venus, not Saturn, Venus makes a very nice little signpost. Mars, you're probably going to have a devil of the time finding. But anyway, there it is.
Brian and I are feeling guilty.
Good. We have the technology. Now, could you change the color from putrid green? Anyway. I guess I shouldn't push it? Okay. So anyway, another little fun Kodak moment. And in case you didn't recognize the big, bright thing a little bit off to the side, they've labeled it Sun. So do not look directly at that, by the way.
I'm nervous to go to the next slide.
Give it a shot. And
Right.
one of the fun things though is that Venus is becoming more and more visible. So you have the great fun of watching Venus. For any of you who haven't taken some time to watch Venus over the space of a few weeks, it is fun because its apparent disk size increases drastically. Changes drastically, I should say, over the whole period that it's viewable, and the crescent is really quite noticeable. And the jury is out as to whether you can see the crescent shape with naked eye. There are people who claim they do it, but then again, there are people who claim that there are strange things happening, and never mind, forget it. But at any rate, but there's some fragmentary references from old histories that suggest somebody may have seen the crescent, so give it a shot. Mercury, again, is going to be nice and viewable for a little while longer, so a good crack at it. So again, Kodak moment stuff, and unfortunately, this time of summer, well, I mean, we're getting into some reasonable evening hours now when you can at least get something reasonably dark, but the last couple of months, it's almost good it's been cloudy because it's very depressing. When it's not cloudy, it's still bright. So the land of the midnight civil twilight. Anyway. I don't know if I can't even remember if I have another. Oh, yes, right. The Perseid meteor showers. Forgot to mention that. And of course, it's nearly a full moon. Yeah, anyway. However, the nice part is the moon is setting around midnight, and the theoretical peak for the Perseids is 2 o'clock in the morning, but basically any time up to midnight. Now, there's a little.
Can you explain the progenitor of that?
Progenitor was, if I recall, Swift-Tuttle. Now, what happens with meteor showers, in most cases it's comet, though there's one case that isn't, is when the comets come by the Earth, they have that beautiful big tail, and they leave a huge pile of dust behind them. And what happens is the tail dust stays behind as a stream that the Earth will pass through on regular intervals every year. And as we're blasting into that stream, we're basically catching a whole pile of those dust particles that are blasting into the atmosphere. So the effect of this is it's like driving into the snowstorm. It gives us the illusion of all the shooting stars, all the meteors coming from a common point. And this is what we're showing here. So if you look at the definition of the Perseids or any other meteor shower, it's, oh, good, the radiant thing must be there. I'm going to look right there. And what you will find is you are sitting there looking at a big empty chunk of sky, because that's not where you look. Basically, it takes a while for these to get up ahead of steam and make a nice little meteor. And they don't all happen at once. Think of this as, anyway, never mind, you get the idea. So basically, I've always been very successful with looking about 45 to 60 degrees away from the radiant. But basically, the Perseids are nice enough that if you basically go out, even to the city, if you can just hide yourself from lights, you're going to see a few more shooting stars than you normally would. And if you can find a nice dark sky, it truly is fun. Until the moon sets, it's going to be hard to see anything, but the moon is setting at a sensible hour. The only problem with this one is it is a Monday evening, so you will have to lie like crazy about why you can't come to work the next morning. I can't come, my dog's sick. You don't have a dog. Okay, it's the cat. Anyway, never mind. So, great fun for meteor showers. Do not, I'm sure most of us know this anyway, but don't bother with telescopes. Don't bother with binoculars. It's a naked eye thing. What you need is a lawn chair and something to keep you warm. Trust me, it gets cold. And Mark 1 eyeballs. So this is one of those beautiful ones that's fun for free. So anyway, there is tons of other stuff in the sky. This is all the stuff that's super easy. All I'm trying to focus on with these is stuff that anybody can find with minimal preparation. There's lots of folks here that'll tell you the really snazzy stuff that will stretch your abilities, but this is all the stuff that you can, grab the kids and go out for 2 minutes. So there's always something for somebody in astronomy, so go out and take a peek. Chris, thank you kindly for fixing
my error.
That's right, fixing your error and making me look wonderful. Making me look like a real nasty, individual. Fade to black. I'll leave now. Go on.
All right. As we can see, next up, Bob Olson, all right, with a talk about his observatory. Is it well, it's not exactly a backyard observatory, is it? It's not backyard?
Yeah,
Is it?
it's backyard.
Oh, is it the backyard?
Yeah, not here though.
Oh, yeah, I know. All right, Bob, go ahead. There's a pointer there.
I got it.
Okay.
I'm loaded, ready for bear. This one is in Florida, much nicer than here. This is a view of my observatory in North Augusta. It's taken from my bedroom window, and just a few things I'd like to show you here. The building itself is about 28 by 24 feet, so it's a pretty big building. And this is my concrete observing pad, which goes behind the building also. Where's that pointer? These poles I'll mention to you later, and this is an unused road allowance behind the building. Open field, and then this is about 2 miles of bush off in that direction to the east. So I have a really nice dark sky where I am. Mount Olson Observatory was named by a friend of mine called Paul Shepard, a very sarcastic sense of humor, and because this is the lowest spot in the area. And you'll see that it shortens down to Mu. Now, before I go much further about owning an observatory, I need to tell you that you have to be a little cautious about your neighbors. Sitting out in the middle of the night with a telescope, looking at things, really raises the suspicions of anybody who's not an observer, an astronomer. And you should really talk to your neighbors about what you're doing. And so they have come over and seen the telescope and see what I look at. And I used the line that my neighbors are all really ugly and I wouldn't look in their bedroom windows anyway. That wasn't as successful a strategy as I first thought it might be. This is the observing pad from the back of the building. So my telescope's set up in the back, and I roll it out onto this pad here. And you'll notice the wheels on the mount. And that's really the point of this is a roll-out telescope observatory rather than a set-up one or drag out or roll off. And there are some things about it that are good and some that are not so hot. This is my observatory from space. I got Chuck to fly up really high, and he entered it in. This is actually Google Earth, and that's my pad right there. And so you can see this big empty field and then forest. So it makes a fabulous sky to the east and to the south. When I look to the north and to the west, I'm looking over buildings. It's only half a dozen or so buildings, but they create in the winter, they create heat waves if I low to the horizon. I'm looking up and over roofs. And in the summer, the roofs are hot. So it's really, I don't observe to the west or the north much unless it's really high in the sky. Oh, I want to show you one more thing. There's my observatory. See this road? Well, there it is from my observatory. I had never stood in my backyard and looked out in the dark before I built the observatory. And then I set it up and put my telescope up, and there's these friggin' headlights aimed right at me, and they light you up like you're a prisoner being interrogated by the police. It's unbelievably bright. And they shine on you for about a mile. So it's just forever. So they have to be blocked. So the solution was pretty simple. I went to an awning company, and they made me a big tarp, and that's what the poles are for. And that the tarp is in a bag, and you just roll it. I can put it up in 2 minutes. It clips to the top with bungee cords, and there is the road blocked. And it works like a dream. The black material is quite light proof, and so it makes my site very dark. Now, a couple of things. You can see the wheels on the mount, and this is the box with all the electronics to run my telescope. I'm an imager rather than an observer, really. So I need to be able to run my filter wheels and my focusers and my telescope mount, and my camera. It takes a ton of electronics, and they're in that supposedly waterproof box. When it rains, I found that it wasn't waterproof, but that's another deal. You see the wires running back into my observatory, and that's where I would control the telescope from. And it takes 2 minutes to put the tarp up and 5 minutes to take it down. Taking it down is a bit of a nuisance, though, because there's always dew on it, so it's soaking wet. And in the winter, it gets the dew freezes. And so you have this big sheet covered with ice, and you're trying to stuff it in a bag. So I actually don't like to put that tarp, I don't like to take it down. And you can't leave it up. So what I do is I block it with a trailer if I'm imaging, because all I need to do is block the headlights. This is no good if you're going to do visual. You need to put the tarp up. But if you're going to do imaging, this is quite adequate. Now, you'll notice the wheels down here are the kind of wheels you find on power tools if you're moving around in a shop to make your tools mobile. You cannot observe with wheels on your tripod. It's just too unsteady. So the wheels have got to be retractable so you can set the tripod back down on the ground. And that's what these ones here do. Okay, two mounts there. One is my Losmandy mount, which I use for visual, and then I have an astrophysics mount, which I use for imaging.
So which is which there?
Losmandy is here, and this is the astrophysics mount here. That's a Celestron 9¼ inch telescope, and this is a Vixen 8-inch F4 Newtonian, which I've just started using for imaging. And here's the foot pedals to run the wheels. Now, there is a bit of a problem with running a thing out in the, onto an observing pad, and that is it's got to be polar aligned. So what I do is I've drilled holes in the concrete, and I've actually lined the hole by driving in a little pipe, so it's a steel-lined hole. And then these bolts just line up with the hole, and I do that on 2 of the arms. The third one just registers automatically. And my mount stays perfectly polar aligned. It actually works very well for a long time. And you can see there, it's just ready to drop it in the hole. The painted on mark is because to find a 1/4 inch hole in the dark on a 16-foot by 12-foot pad is not all that easy. So I find it easily with the black paint. Now, the pad actually does heave a bit in the winter. So I do need to polar align every once in a while. I polar align 3 or 4 times a year just to check it. Usually it's fine, but sometimes it's a little bit. And pads are terrible for vibration. So if I'm doing imaging and I'm stomping around, I'm going to see it in my image. If I'm doing visual and I stomp around, I'm not going to see it. So for when I'm doing imaging, I've got to stay off the pad or tiptoe around. This is the different kind of wheel, exactly the same use. It came off a power tool, and it's on my Losmandy mount. This mount, by the way, came from Attila Danko. And Attila glued on hockey pucks at the bottom of the mount. By the way, the levers give you about 1.5 inches of travel, which is fine for concrete. You certainly couldn't run it over a driveway easily, but concrete is fine. Now, why a rollout observatory? A pier with a building with a roll-off roof or a dome is certainly more convenient, and it's no more expensive than what I've done. So this is not a cheap solution unless you already have a garage you're going to run it out of. But I fool with my telescope all the time. I'm always changing the scope or the filter wheel or the filters or just all the time. Camera, just changing stuff all the time. And I've done that in other people's scopes, and you're cramped, you're dark, it's cold, you're getting eaten by bugs. Working on your scope out in the open in an observatory is a pain in the neck. So when I run it inside, it's easy. It's an air-conditioned, heated building. So it's easy to work on. All right. When I do run my scope outside, though, you run it on the wheels and you step on the lever and the thing clunks down onto the ground. It doesn't keep synced to the sky. So it'll vibrate a little bit out of sync. And so the scope doesn't exactly know where it is. So I then have to go out and visually, with a finder scope, find a bright star and then sync my scope to the sky. And it takes just seconds, because it's going to be almost on the star. So it's just a matter of giving the thing a little bump with your elbow and you're back in business. I can go from inside to outside in about 5 minutes. I can be up and running in 5 minutes from when I decide to image. That doesn't mean that I can image in 5 minutes, though, because my scope is usually a different temperature than the environment. So then I have to wait for the scope to either be hot or cool down or warm up, depending which way what the temperature is outside. This is a view from inside. This is my computer that I run everything with, and you'll see the scope in the background. Now, I store my scope parked in a parallel, the scope is parallel, and the counterweight shaft is parallel to the ground. That allows me to get even a big scope out through the door. The first time I did that, I didn't, and I smacked it right into the door. Yeah. The button just stuck. All right. Where was I? Right here. Sorry about that. So anyway, this is the scope looking inside. You can see the wire running into my computer inside. The scope is now looking northwest. This is all closed up, and it's very light tight. I've made a real effort to make sure that the inside lights don't come out to the outside. And that's, I don't like to work in the dark, so that makes it really nice for working on the computer. Now, the pier that I use is a stainless steel 8-inch pipe, and I bolted these aluminum blocks onto them, and then I slipped the legs over that. It's an idea that I stole from astrophysics in their portable pier. The problem was they use an aluminum pier, and I'm using a stainless steel pier, and stainless rings a bit. It's got a little bit of spring to it. And so I had to put these reinforcing bars in to keep it from being too flexible. And that worked fine. This is what it looks like just before you slip the legs on. And then there's a cable that runs from here up to there, which sort of holds the whole thing together. It's a great trick that astrophysics came up with. This is my buddy Paul Shepard. We do a lot of visual with Paul out there. Paul's a visual observer, and I will observe when I'm with. Let me put it this way: astronomy to me is a social event if I'm doing visual, and it's a solitary event if I'm doing imaging. So when friends come over, we do visual, and I have a nice dark site. Friends often come over, so Paul's probably the one that comes over the most often. This is Jim and Ann Baxter, just friends. They don't even like astronomy much. But they like looking at the bright, common things. So when they come over, we often roll the scope out if it's clear and take a look around. Now, this is winter maintenance. You know, this is when I wish I had a nice dome. You got like a foot of snow, and this winter, of course, we had hardly any snow at all.
No.
Yeah, and so you got to keep it clean, because if it's not clean, then you won't go out when it is clear. So, you know, every time it snowed, I was out there with the snowblower, keeping it clean. And it takes me about 10 minutes to clean it off. I would snow blow it, and then I would shovel it with a push scoop, and then I actually use a squeegee on it to make it really nice and dry. Now, let's just take a look again at my observing site. There I am right there. And this is a big open field with 10-foot high grass, and this is 2 miles of woods. And I'm out in the dark. This is what it looks like from my observing pad in the dark. This is sort of a spooky looking big field. And the wolves are there all the time. You hear them howling. The coyotes and the wolves are just howling all the time. I'm out in the country. And I normally don't have a flash on when I'm out imaging. It's quite dark, and the wolves are there. And you know, they can play with your mind. And then about about half a mile over in that direction there's a guy who has the beehives, and the bears are there all the time knocking his beehives over. And actually, Paul Shepard, his son, ran over a bear about 5 kilometers away from where my observatory is. And I want to tell you, if you have a choice between running over a raccoon or a bear, choose the raccoon. All right? It did a lot of damage to the car. So there's bears. All right? And then there's always some idiot who reports that they've seen a cougar, mountain lion in the area. I have my doubts. And then just recently there was a report that the ministry has released 6 cougars in our area to eat the fishers, which they released to eat the porcupines. Highly reliable sources, I'm sure. But in the middle of the night when you're tired, it plays on your mind. And so, you know. And actually, the animal that I'm really the most afraid of when I'm observing in the dark and can't see anything, you know, you go outside the door and you don't know what you're stepping on. Our neighbor's cat was sprayed. It's 100 meters away from my observatory, was sprayed this week. So you know that they're there, and I haven't been sprayed yet, but I would imagine it's just a matter of time. Absolutely, yeah. But you know, seriously, in the dark and you're getting tired, the thing that really, really scares me is this fellow. And you're not going to believe this or not, but sometimes I'll be going back into the house from observatory, and the adrenaline rush I get when I think of vampires or werewolves or whatever. Now, I really have to tell you that if it's clear, I'm out observing, almost for sure. So I've been getting a lot of sleep this summer. Yeah, but actually my other hobby is golf. No, wait a sec, that's not good. So this is a picture of my observatory not very many days ago. And I would be remiss if I didn't mention my wife Ginny for putting up with me all this time with my observing and all the time it takes. And I tell you stories, but actually she's here tonight, so I'll save those for another talk. Now, I just before I finish, I really should tell you one other thing. Brian gave a real nice talk about the Mars lander, and Richard Harding's sitting beside me back there, and his comment was, the little scoop is going to go out and suck up a little Martian, and they're going to bake him in an oven, and they're going to declare war on Earth.
That was excellent, Bob. Thank you. Now, looking at that skunk, that reminds me that Pamela Wolf, she works at Carleton University, but she's also one of the astronomy educators here at the museum, and she told me about 2 years ago, she was walking down a darkened street in Canada, and she felt this kitty cat brush against her leg, right? So she reached down and was scrunching it under its ear and thinking, my goodness, this cat sure has a coarse fur, coarse hair on it, eh? And then she saw the double stripe, and then nice kitty cat, nice little moufette, huh? All right. Okay, next up. Yes? Yes, no, yes.
Break?
What's that?
You wanted the break?
No, we'll do this first, yep. Okay, Mike, you ready to roll on your... Okay, so next up, Mike Earl, he's got some images and a bit of an observing report. Come on up, Mike. A bit of an observing report on the two novae that were discovered in the constellation of Ophiuchus, the serpent bearer. Mike.
Okay, Mike.
Don't worry about it. Don't worry about it, Chris.
I can just skip right away.
Yeah, no problem, Chris. Okay, thanks a lot, Brian. I saw the first shot there was the shot of the Novae Ophiuchi 2008, number one. About 2 months ago, Japanese astronomers found a nova that was in our own galaxy that was approximately 10th magnitude near the end of May, actually. They found it. And about a week later, they found another one only about several degrees away from the first one. And I thought that was a fascinating thing to have, two in almost the same part of the sky like that, which is, I've always found it just an amazing coincidence. But as you can see marked here is the actual object. This is taken in color. And you can take a look at how red this is compared to all the other stars, mainly because it's most likely much further away than any of these stars in the shot. Most likely it's tens of thousands of light years away. If anyone knows the actual distance, I haven't seen any published distances yet for this object, but it's very difficult to find because there are a lot of variables in it. The absorbing dust between here and there, how bright the nova actually is. So there are a lot of variables when thinking about this. I want to show you this first, actually. This is actually a spectrograph taken by one of the discoverers. And you can see here that anything past about this area, 7,000 angstroms, is infrared. And anything below 4,000 angstroms is ultraviolet. And anything in between is basically our spectrum, purple to red. And you can see most of it is in actually red part or infrared part of the spectrum, and that will be that's a very critical part about part of what I'm going to be showing tonight. So obviously it's a very red object, as you can see here. This was taken on the 22nd of June. I know the coordinates of these two objects off by heart now. I've been seeing this thing so many times over the past couple months, but of course, as Bob was alluding to, I had real trouble observing these. I've only had about maybe 10 observations over 2 months, which is really bad, actually. So this is a CCD image taken on one of the first days I looked at it. And you can see it's quite bright here. The limiting magnitude of this shot is about 18 or 19. And you can see that the object is fairly bright. It's one of the brightest objects in this shot. It was about 10th magnitude at the time. And cut to 2 months later, last night actually, and that's what it is, hardly dimmed. That's incredible. I mean, it's dimmed a bit, but not very much. Now let's cut to the second one. The second one was discovered at the very beginning of June, actually about 3 days before this shot was taken. And you can see here, it was quite a hazy night. As you can see, the stars are quite puffed out, and there's not many stars. The magnitude here is probably not even breaking 16. But you can see the star here. It is quite bright, 12th magnitude when it was discovered. And 2 weeks before, there was literally nothing on any of the survey plates. So I had originally thought that maybe this object was older than the first one, and it was dimming down when they found it. But this was actually one of the brightest it had. Now cut to yesterday, last night, it's now about 18th magnitude. So these two objects are amazingly different. The first one is taking a lot longer to dim, whereas the second one has dimmed right down almost to below the noise, just 2 months and just 60 days. So here's a little graph I made of all the, as like I said, only about maybe 10 observations per nova. It was just a terrible summer, I must admit, but I did get some data from it. And day 0 is June 3rd, and day 59, that's yesterday, last night. I had an amazing stroke of luck in Brockville. It cleared up, and there were these clouds in the west. They were just sitting there, but they weren't getting any higher. The problem with these novae are only about 20 degrees above the horizon at highest. So when there's any clouds around, they tend to gang up on these things quite quickly. So I wish there were some that are around zenith. That would be nice. But these ones, unfortunately, were not in the cards for that. But you can see the difference between these two objects. This is amazing. As you see, this one here starts at 12 and just falls like a stone over 2 months. This one here basically dims a little bit, and it's still dimming a little bit. It's now sitting at about 11.6 magnitude. But I'm basically seeing that the infrared radiation may be the reason why this object looks much brighter than it actually is. This one could be pumping out a lot more infrared radiation than this one here. Because I've seen some reports who have taken in visual filters, the visual spectrum filters, that they're reporting about 13.5, 14th magnitude for this object, and I'm seeing 11.5. So I'm detecting the infrared radiation. My camera, most CCD cameras without any special filters will just take infrared right in. The low bands, anyway, of infrared, so you can actually see it coming right in here. Hey, Gary.
Just wondering, on Nova 1, on day 32,
Right.
night 32,
Right.
how come it's brighter for a bit of a time?
Yeah, that's error. Yeah, it's just an error. I mean, I tried to get it as accurate as about 0.1 magnitude. I mean, this is a very small little change. Normally what you do after the end is just have a trend line going down for each one. There are sources of error in this, of course, because you have different humidity for different days. You may have some cloud coming in, and temperature as well. It can be quite different. Also, you may not get as many pictures. I mean, pictures you saw before were basically shots that were resulted of stacking. And some I stacked 20 shots, some I stacked 50 shots. It depended on how many I could get before the clouds invaded. It's like a minefield almost. You're like tiptoeing through it, and all of a sudden, bang, it goes off, and then you have to take everything in. So is that the last one there? Oh, yeah. Yeah, one little announcement here. You kept it with us, so that's good. The middle of KINTAIL in Almont is hosting 2 star parties. One on August 29th, the other one on September 26th at the middle of KINTAIL Gatehouse in Almont. You can go to caster2ca/parties, and all the information is there. Location maps, weather maps, when near the day, of course. And I'm not that good. And special objects that you can see. We've got Jupiter, Uranus, and Neptune all ready to go. So it's a free admission. All are welcome. Tell your friends. Tell your friends and family. You can train, if you have a parrot, train it to repeat it. If anyone walks in the door, they can just say it. Yeah, saves you time, So that's it for that, and I think I'm done. Okay, so that's the Nova. Any questions? You can search me out afterward, and there's a lot of questions about these 2 novae. So.
Any questions for Mike here or comments on the? We'll applaud in a minute.
I can do it.
Will, Mike, I did have a question. He said
Sure.
it only appeared about 20 degrees off the horizon.
Yeah.
Are most novas fairly low like that?
Oh, they can go anywhere. They can be anywhere, basically. Some have been in Aquila, some have been in Hercules. I've heard a few reports of that, yeah. I mean, basically, statistically speaking, they can be pretty much anywhere, but in our own galaxy, in the disk, right?
Yeah.
Yeah, Novae, in our own disk of our own galaxy, yes.
Right.
They are basically confined to that strip. But the Milky Way could be straight up, right? Cygnus. Yeah, so.
Okay. Thank you.
Yes.
Mike, how bright did Nova go to when it was first detected?
10.
Can you repeat the question?
Oh, I'm sorry. Yeah, he was asking how bright Nova 1 got when it was first detected. It was about 10th magnitude when it was first detected. It didn't get any brighter than that, but people have been predicting this one may actually get brighter. It may actually come back. But this was back a month ago, and I don't know if it's gonna. I can't say. No one can say actually. It's a very difficult. These things are almost totally unpredictable. They can start to come down, and all of a sudden, bang! They can be double as bright as they were when they were first detected. They're very interesting. Yes.
How often are these nova being detected?
How often?
Yeah.
Well, you mean the ones in our own galaxy?
Like, are you seeing them a couple a year or?
Well, they are totally random,
I
but
realize that, but
I get about 2 or 3 a year, but it depends on the brightness too. I mean, the stars, both novae that we saw, we never knew they existed. The stars, we didn't even know they existed until just 2 months ago when they brightened up. See, that's why that's why these stars are certainly tens of thousands of light years away, because normally, if they were any closer, you'd be able to see them, or at least detect them on surveys down to 22nd magnitude. But it basically is a random event because we can't predict what's going to come in. Okay.
Any other questions or comments? Paul?
No.
Just wondering, I know the magnitude scale is not linear, it's sort of a...
Logarithmic, right.
Okay, so, it's like, how much of a difference is it between 12 to, I guess, 19?
Not 12 to 18?
Can you explain what?
Oh, okay, yes. Well, the magnitude scale is based on a power of 2.512. So a difference of 2 magnitudes is 2.512 squared. Difference of 5 magnitudes is 2.512 to the 5th, which is 100. So it's approximately 250 times between 12 and 18. Yeah.
All right. Okay, thank you, Mike.
Okay, no problem.
Okay, we're going to be breaking in just a moment, but just before we do, I'm thrilled that we've got somebody very special in the room tonight. We have one of our newer members, Gordon Webster, who's here this evening, and the person I'm really, really happy to see tonight is Concepcion, his wife, who's been it's been the grand saga working with the Canadian government to come in from the Philippines, and very happy to see you here, Shoni. So, welcome to Canada. Thank you. All right. So on the heels of that, if you don't have a ticket for the door prize draw tonight, come get a ticket. You don't have to be a member, as I mentioned, and no double dipping on the ticket box. All right. I know some of you guys. Waldy, I'm looking at you. We're into the observations, and I have my little tokens here for people who give observing reports. Yeah. Okay. What's up first? Rob.
There have been clear nights. Some of them have been cool. Some of them have been very hot. And when they're hot, of course, there's lots of mosquitoes. So there's this thing called a thermocell that was reviewed in Sky News. I got one of those things, and by the way, they do work. Empties your pocket pretty quickly of money, but it works very well. But to save money, I figured I don't think I want to go out there. And so this is taken through the screen of the veranda of my cottage. Yeah. And I must admit, it was great to see the mosquitoes swarming outside as I briefly just blew on the screen to entice them to get closer. But it just shows in particular, lots of trees are growing up in front of the cottage on purpose because of all the cottages that are now developing across the lake. And I wrote an article for the Rideau Valley Conservation Authority about light pollution, and within 2 weeks, literally 3/4 of the properties turn their lights out at night. Oh, fantastic. Except for that one guy But that's, as you can see, it's in the north, and whoever looks at the north, except to take a pretty picture.
I
Anyway.
look for Santa there.
That's right. Okay, if you have any questions about that, it's actually took a little bit of work to make it look the way it looked to the eye. I do that with these pictures. You can't exactly reproduce what you see with your eye, but you can. It doesn't take much work to make it look exactly the way it looked. That's the way the sky actually looks to my eye. The sky is pretty transparent out there.
Rob, how did you shoot through the screen?
The camera was about 3 inches from the screen.
Out of focus.
Yep, the screen was out of focus. In fact, you look very closely at it, you'll see a little bit of patterning in it.
Yeah.
And that's from the screen.
We were wondering if we could have zoomed in on that. We could have seen the cross-screen effect there. You'd see the stars would have the points coming off the top and the sides there.
Oh, and it's a Canon Rebel, the second version. That's the 8 megapixel version. The 10 is a little too many pixels for my computer anyway. And standard lens that came with the camera.
You sure milked a lot out of one slide. Jeez. Very good, thank you. Excellent. Thanks, Rob. Okay, Gary?
Thanks, sir. Just a couple of slides here tonight. Wednesday morning was very clear at 10 minutes to 5, and just opened up the shade in the bedroom, and there was the moon, so I ran downstairs, snapped about 3 minutes before the clouds actually covered the moon. And again, with the Canon Rebel XT, with the regular lens on it, 75 millimeters, 5-second exposure at ISO 100 on a tripod. So this is the star Mepsuda, and it's part of Gemini, which means that Orion is rising up early. We're in August now, so people that like Orion, it's a season of shoveling snow, it's almost upon us. And just some information about the star, which I have on one of my blog sites. So this star is actually 900 light years away. And in essence, it's pretty large, 150 times the size of our sun. In fact, if you replaced it for our sun, it would take in the orbit of Venus. So it's quite large. And here's where she was in the sky. I was very surprised. And of course, that night, I think they called for thunderstorms and chance of thunderstorms, and it was just a clear sky. The weather forecasting has really been atrocious this year. I like Granny Clamet's weather beetle instead.
Gary, just to repeat your point about Orion there. Really
Yes, Orion on the far right-hand side. Orion is coming up soon, and I have no idea how this works. Okay, next slide. And well, the processing of Jupiter is getting a little better. And a great segue for what Tim was saying on August 6th, 7th, when we have the transit of Io. Tim mentioned it's going to be around 11:30, and Jupiter's well placed in the sky for me, so I will be webcasting that night, astrocasting as I call it. And so those of you that do not have telescopes, if it's a clear night, get on your computers. wondersofastronomy.com is my website, and there's a link to Live Yahoo. And let's hope for clear skies and actually a beautiful transit across. Who has seen it, with your applause, who has seen a transit? And who has not seen a transit? About half and half, so let's hope it's clear that night.
Gary, just wondering, did you have an improvement on the edges on that from last month's shot? Because you took one last month, and you said you were having problems on the edges.
Yes, again, it's the settings with the scroll bar settings. When I first took the image, Rolf was excellent on some of the instructions. I had the brightness way up before, and I was getting these stupid rings around. Yeah. So now I brought the brightness down about halfway, and now using the gain instead, and that made a huge difference. And also with the workshop that Rolf graciously had at his house, really helped with the processing. Now, Rolf has always said use higher f ratio, f30, f20. I've tried, but turbulence is just so bad. This is only at f10. I've tried higher, but it just gets too fuzzy. You really can't see in detail. But at least we have the great red spot over here, which I'm pretty happy. Okay, thanks a lot, folks, and hope to see you online on August 6th.
Great, excellent. Thank you, Gary. Paul, did you want to talk about that from...
No, it's just, this is in a good place to observe. It's in Vulpecula. It's about a 9th magnitude object, and I thought since it's current, it's nice to show something that is around these days.
So a nice 9th magnitude object in Vulpecula. That's the M27, also known as? The Dumbbell Cluster. All right?
Nebula.
Oh, Dumbbell Nebula, yes. Cluster Nebula. I was.
You can't get away with mistakes in this group.
I don't multitask well. Sorry. All right.
Someone was asking Paul a question.
Oh, question for Paul. Yes.
What camera? An SD10XME.
He speaks in code riddle. I like that.
Well, that's the Santa Barbara.
Santa Barbara Instruments Group. S big.
And I have a Meade 14-inch, and I'm using it at f6.3 with 2x2 binning.
All right. Any other comments or questions? Okay. Avancez.
Thanks, Brian. I have a few shots this evening. I've been playing around a little bit with imaging, and I thought show some interesting shots I took over the past couple months. This is a shot I took actually on July the 1st, actually, Canada Day, just before the fireworks went off. This was the. This picture looks like almost like the sun's out, like you're like at a nice summer day and there's a clear sky, a rare clear sky over the summer. But you can see this little thing right in here. This is an interesting effect when you kind of overexpose with a camera. This is a Nikon 4500 Coolpix I've had for several years. And you can see there's Jupiter right there coming up, just rising at that time. Of course now, about a month later, it's going to be about up here at the same time. As Tim was alluding to last month, actually he literally said it last month. Right, Tim? No.
That's right.
Okay. There was a nice pairing conjunctions, actually several of them over several days on July 4th, 5th, and 6th and 10th, I believe. And this is one of them. This is a nice triangle effect with the first crescent moon, Mars, Saturn, and Regulus. And so it makes a nice little triangle effect right there. Not very much scientific value, but it makes you stop and smell the roses in astronomy a little bit. You know what I mean? It's a lovely. I'm sorry?
It's a Kodak moment.
It is a Kodak moment. You're right. Yeah, exactly. Yeah, I got this in Brockville. It was had a nice horizon in the west, so I thought to get this shot, and you see the Earth shine there quite well. Yeah, and as Gary was alluding to in his observation talk there as well, the difference in the distances of each one of these objects. The moon is about 385,000 kilometers, Saturn about 1 billion kilometers, Regulus too large to really count, 77 light years would be more precise, and this star here is probably even further out than Regulus, so that's part of Leo as well. And this was taken just about maybe half an hour after sunset. Now, one great thing about living in Brockville is that you can see the fireworks on the 1st and the 4th. And this was a shot taken across St. Lawrence of Jupiter and fireworks going off in Morristown, which is near Ogdensburg. And you can see, I like this effect here. You can really see the red on the water. And but sometimes the juxtaposition of celestial objects and terrestrial objects makes a nice pairing.
So that's Homeland Security trying to shoot down Jupiter?
Probably.
They missed.
Yeah, exactly. Yeah, and there's a message after that. The message sent to them: "Stay away from Europa." Another shot of.
Everywhere else, though.
Yeah, exactly. That's true, and that's the problem. Yeah. And here is a shot again of the fireworks, just down here in Morristown, and here's Scorpius coming in as well, and just a yeah.
What's happening with Delta Scorpii these days? Because remember it was.
Yeah, these days. Well, it was what, 5 years ago I started doing that, something like that. It started getting brighter, and it's staying there. No one knows why. It just happened to brighten up, and it's not dimming down anytime. I remember when all three of these stars were basically nearly the same brightness, right? Yeah. And all of a sudden, Delta came up and said, "Nope, I want to be different." So.
Can you tell us about the reddish one in the middle of?
Right here.
Yeah.
Well, that's Antares. That's the brightest star in Scorpius. The heart, basically the heart of the Scorpion. Scorpius is one of those constellations that amazingly actually look like the name it's trying to describe. Like Scorpius, a scorpion. You can see these are claws right here, and you can see it goes all the way down. And there's a little tail like this, so it actually looks like a scorpion, which is amazing to me. And most of the constellations, like Canis Minor, for instance, like it's a wiener dog or something. I don't know what that's supposed to be there.
It's a balloon dog.
A balloon dog. Oh yeah, that's good. But it has no head.
Well, that's from somebody who doesn't know how to do it yet.
Oh, Antares? I don't know, actually.
But
I think Antares goes out to orbit of Mars, does it not?
Antares?
Yeah.
About that.
Yeah, about the size of the orbit of Mars.
It's roughly the same size.
Yeah, it's basically what happens when a star starts losing fuel. It starts to balloon up a few times, and then you get basically what's called a red giant. And this is basically a red giant star. And
That one's the red supergiant.
is it a supergiant?
Yep,
Okay.
that one's a supergiant.
Yeah, about over Mars. Not surprised.
Which is the star that got brighter?
This one right here, Delta.
Okay.
Delta Scorpiae right there. That's the one that got brighter.
She's no longer the fourth brightest.
Right, exactly. That's the thing, yeah. What you do with those nomenclatures when yeah. Well, I can't predict that.
The charts.
Yeah, it's like 34 Tauri. That was Uranus, right? Well, it moved. It's gone.
35 Tauri. 36 Tauri.
Yeah. Okay, here's another shot of the fireworks down here. It's kind of boring, I know. And there's Jupiter right there, and you can start seeing Sagittarius, which is over in the edge here, but it was kind of very hazy, as you can see here, but yeah. But the stars up here you could really see very well, so they started getting a little better. I actually got this object. I was promising myself to get this object for God knows how long, and I finally said, okay, I'm going to do it. So I'm amazed that today you can actually get the tail of these things. This one here is a little dimmer, but you can actually get the tails of the ringtail now with backyard telescopes, which is absolutely phenomenal to me. I remember as a kid seeing these amazing, observatory shots of these amazing objects, and you couldn't get them with an 8-inch scope and a 35 millimeter unless you really had a lot of patience and a huge amount of chemicals, as it were, to push the film and so on and so on. But with a CCD camera and 11-inch telescope, you can actually get it. And this, the ringtail is not one of these objects that are straight up at zenith. This object's about maybe 25, 30 degrees in Corvus, basically. That's where the object's located. I always think that looks like a shrimp or something. It actually looks like a little shrimp. And that's the first thing you see. And then you start stacking the shots. You start seeing the tail come in, which is absolutely amazing. Now, this is what I like to do sometimes is to take my wide field, it's basically a 35 millimeter camera, a 50 millimeter lens for a 35 millimeter camera, and to fit it on my CCD camera and take shots of 12 by 12 degree images of the sky. And this is one of them of the constellation of Sagitta, the arrow. And there it is right there. And it's hard to pick it out without the visual aids. Thank you, Chris. Without the visual aids. But this guy right here looks a little fuzzy. That is M71. And I think it's amazing at a 12 by 12 degree field of view, you can actually still see M71, which is not the brightest of globulars in the sky either. But in the Milky Way, you can see it coming through here, and which is pretty interesting. Limiting magnitude of this shot is about 10. So I could have, and it's possible for me to discover Novae in the Milky Way because of that last one. That first one was magnitude 10 when it was discovered. So it's possible using a blink comparator and several images of the sky, I could probably get something like that if I had the patience to do it. Yeah, where is it? Oh yeah, that's true. That is very cool.
Yeah, there it is.
Yeah. So if you get a CCD camera, put a very low, like a wide field lens on it. It's just amazing what you can see with it.
And Mike, it
Yeah.
looks like you got M27 up there too.
M27, really, where?
Shot small.
I think
Top left.
top left. Up in here?
Thing
Right there? Right there. Yeah, it could be. I remember getting the whirlpool with this, and it was like you can see the two components. You can actually see them; they're very close together. You could actually see the two components, which is, I think, it's a phenomenal thing to do these days.
Okay, so remember about M27.
Mhm.
All right. Well, we had Paul's.
Right.
That's going to be coming up as one of the observing challenges. So.
M27?
Yeah.
I didn't think it was M27.
What's that?
It wasn't M27.
We're doing two.
Oh, okay, fine. Yeah, okay. And another great thing about CCD cameras is they can really pick out that Milky Way. This is the Scutum star cloud right here, and you can see it all its glory. Unfortunately, it's not color. Well, it actually a black and white one's more sensitive, so it's good to pick this out. This shot was about 30 seconds exposure.
They make filter films.
Yeah, I know they do. Yeah. Well, yeah, mine's guided. You can do that. That's true. And but I like taking shots just 30 seconds, a minute. So it's guided. Basically, I piggyback the wide field onto my 11-inch telescope, and I just let it guide through the thing. And it's centered basically on, this is M11 right here, the wild duck cluster. I mean, you can't see every individual star, of course not. But
It sure looks like a duck.
it doesn't it? Yeah. I think it was like a drunken admiral named that one or something, right? It had to be.
Oh, yeah, well, actually, it was baby duck.
Baby duck, right. Yeah, baby duck. Another galaxy I really wanted to get was the sunflower. It's kind of challenging because you have all these really, really mottled areas here, and you really want to get that detail in there. I took about 100 shots of it and stacked them up. Just basically Registax did this. And the stars are not bad. This is almost at zenith, so the limiting magnitude here is about, I'd say 18.5, somewhere in that area. And one thing I like to do once in a while is just point the scope right at zenith, take a huge amount of images, and see how far down I can get, the limiting magnitude, how far I can get. So far I've gotten about 20, I'm sorry?
The Mike Deep Field?
Mike Deep Field, right. So far I've been able to get about 20, down to 20th magnitude, but I can't really push it down any further than that. And I'm using a large pixel resolution. I'm at about 1.56 arc seconds because my primary is not taking lovely high resolution images, it's satellites. So you got to be able to detect satellites which are moving across the array. This is like a little galaxy UGC 9703. Nice little structure in there though. I mean, it's like a nice little edge-on galaxy, probably a spiral, but it's, that could be a good a challenge object. I don't know if you can actually see it through an eyepiece, but it's not much. It's probably not much worse than Hickson 61. Right? That's a nice one. I love this one. I took this shot. I said, just picked it totally at random. I said, hey, I'm going to look at this one. I did, and wow, look at that. You can see this nice little. Every single galaxy is totally different when you take a look at them, aren't they? I mean, it's just you can see. And just imagine how far out this guy is. We're talking probably about 100 or 200 million light years away. Something in there could be looking at our Milky Way and saying, wow, look at that, which is absolutely incredible. And UGC 10627. Here's a nice little spiral as well. You can actually see little spiral arms on the UGC 10845. You just take a whole bunch of shots, stack them together, and you basically get a signal rising above your noise floor and that's randomizing your noise. So you get a nice popping out of the detail here. And I just love doing that from time to time, when I'm bored or something and I'm not many mosquitoes around, at least I can get my work done fast. I said, okay, I'll take another shot of something else, just see what it looks like. And that's it. And that's my observing for the month. And I'm surprised I got that much.
So this is basically the first astrophoto I took with this camera. I took a few test shots before, but my first digital SLR. Oh, I'd like to thank Bob Olson for some advice on the histograms for adjusting the colors and brightnesses and so on this. Bob, of course, is much more proficient at this kind of photography. I guess I should say what this object is, although probably most people have guessed it's the North American Nebula. And 20 minutes, but it's 5-minute exposures, 4 of them stacked. And let's see, what else can I say about that?
Can you point out the pelican there? There's a pointer.
Oh yeah, there's
a pointer there.
Supposed to point out the pelican.
It's this
I
way.
barely know what that is.
It's right there.
I think it's this.
Yeah.
But I mean, there's better pictures of this. Well, so I'll probably take more pictures over time and stack them, but 20 minutes was all I could take. Oh yeah, the other thing was that this is just the zoom lens that came with the camera, but it's a little bit cropped, so it actually shows quite a bit more in the full field. But this is cropped; it's about a third of the whole frame.
And you're in Cygnus there, April?
Yeah, that's just about pointed straight up, and on one of the few clear nights we've had, I guess.
First
That's
one,
it.
second.
Next slide. So this is Jupiter, again, on one of the few fairly decent nights we've had. And again, I did apply some of the ideas that Bob Olson had on the histograms, because I found that The program that came with my Canon camera actually has a pretty good program for doing adjusting the histograms, and it was free. That was the main thing. Free with a $2,000 camera, but anyway. So that, but that way I was able to get the color balance very accurately. So I know how to do that now. So, and that's it. I don't know. Any questions on this picture? Oh yeah, the red spot. So the red spot is just peeking out here. I think it was just going off the disk at the time. Very difficult to get any decent images of Jupiter this year because it's very low, about 20 degrees up, I guess. So.
There aren't any shadows on there, are there, of any of the moons?
No shadows. These little spots are just spots.
Sorry.
Okay.
Thank you, Ralph.
Yeah, I've always wanted to see a quasar, and so when Attila came up with the idea of the double quasar, I actually listened to it at the meeting and then went home and I forgot what he had said, which is not like me and Attila because I normally remember every word he says. But I forgot what he said, so I had to actually send him an email and ask him, what did you talk about? And so he sent me the coordinates of this again. And what you're looking at is right there. That's the double quasar that's being gravitationally lensed by a galaxy and between us and it. And those quasars are 8 billion light years away. I think the galaxy is somewhere halfway between us, they think. And just to reiterate what Attila said is that the spectrums of the two are the same. So we know they're the same object. And that the light path of one is about 1.5 years longer than the light path of the other. So, when one wiggles, the other one wiggles 1.5 years later. So we're pretty confident that those are quasars, the same one. Anyway, the galaxy is something around 14 billion light years across. So this is, I have to admit, even though the image is not very good, I was very excited to take this picture. I should tell you that those quasars, I think, are 6 arc minutes apart, and I took something like 30 images, and they only resolved in about maybe half a dozen of them, and so then I stacked that dozen. So it's basically 12 images, 4 minutes long. So that's how many images were used to get this final result. Anyway.
Well, what magnitude was that quasar? I forget.
No idea. Sorry.
It's around 17, wasn't it?
What was the question?
What's the magnitude of it? I don't know. Sorry. I was I read all that when I was researching it to find out where this thing was and what it was doing. When in my individual images, I could see separation on just some of the images. My camera resolves typically about 3 arc minutes accurately. So this was pushing the limits of my equipment. Okay.
Okay, here we get into our challenges for this month. Mike, you going to talk about this guy? Sure.
Thanks, Brian. In desperation, Brian came to me and wanted an object. So
Did I look like I
yeah,
was in
yeah, you were
desperation?
desperate. Yeah, Mike, I gotta get an object. Please help me. Anyway,
This is during the raffle break.
that's what it was. Yeah, it was during the raffle break. Yeah. Anyway, this is a challenge object. In fact, it's not entirely what I'd call a challenge, not in the sense of Hickson 51 like some of Attila's picks are, but I thought I'd make it easier on people with by picking this one instead. And this is NGC 5907 in Draco. This is the only problem with this galaxy, the reason why it can be considered a challenge is because it is quite edge on. And anyone who's visually observed the galaxy nearly edge on can attest that it's quite difficult to see. Not the ones that are closer like NGC 891 in Andromeda, but this one here can be seen with an 8-inch scope in a fairly dark sky with a say 30 arc minute field of view, eyepiece 30 arc minute field of view or so. Those who've done the deep sky, the finest NGC, I think this is one of them. It is a nice object. When you pick it out, of course, averted vision works best with this kind of object, and when you look at it, try to see something that's almost like a needle on its side, and that's exactly what you see. But it makes it a very kind of a challenging object for those with smaller scopes. I wouldn't recommend it with anything less than 8 inch though. Maybe a 6 inch, you might do it in a really dark sky, but other than that, like I said, Draco. Yeah. I remember seeing that one in the early 90s when I was on a galaxy kick, looking at all the galaxies I could possibly get with a old Criterion 8 inch. But but I did get it with it, so if I can get it with a Criterion, you can get it with one today, because the Criterions were not known for their superior optics. Thank you very much.
Okay, thank you.
Okay,
I'll
Brian.
need the clicker.
Oh, yes, I'm sorry. Yeah, I'm going to steal it on you there, Brian.
Yeah. All right, good, thank you. Thank you, thank you. And Draco, of course, is a constellation that snakes between the two dippers in the northern sky. All right. The other Deep Sky Challenge, we try to have a couple of levels of challenge for objects, and Paul talked about M27, the Dumbbell Nebula, right? Okay, and that's in the constellation of Vulpecula. Vulpecula, the Fox. All right, after the Fox, there it is, M27.
About 9th magnitude.
About 9th magnitude. Now for
As you can see in a small scope, you don't need a big scope for this.
right, so a small scope is all that's required for sure.
Or binoculars even.
Binoculars, yes, if you have a dark sky, a good sky for sure. If you're looking for finder charts for either M27 or NGC 5907, if you Google those numbers, you'll get lots of information there, and we didn't put up finder charts for them tonight. All right, so Lunar Challenge. Now I picked this. This is Gary Boyle's image. All right, so he's taken a nice, excuse me, he's taken a lovely photograph of the moon placed against Mabsuta, a relatively bright star alongside it. So for the challenge, this is just pretty picture challenge. Who else can come up with a nice image of the moon alongside a bright object? Notice I didn't say what kind of a bright object, right? So celestial and or slash otherwise. All right, so if you want to have a bit of fun with something there, go for it, okay? All right, some basic information there, all right? But this is all blah blah stuff. Let's move on here. 89 of us stalwarts here tonight. All right, here we are. The observatory is closed tonight. We don't have an educator assigned from the museum tonight, so we can't open up the observatory. Stamont Library, Estelle, you're here, right? Okay, so Estelle will be opening up the observatory, which will be just on...
You made that same mistake last month.
Did I?
Yeah, you did.
Oh, well, let's stop taping this and catch me on my mistakes. All right, the library, of course, the library is just on the other side of the wall, right here. Okay, loan equipment library, Al Scott, he can set you up with, we have some loaner telescopes and that, okay. C. Art Fraser for membership cards, but not tonight. He's away, and Linda Meyer is helping out in the back. She's got drinks and cookies set up there, and a little donation pot there. Okay, and it's already marked. Geez, you're quick. Hey, he taps all this stuff in. It's fantastic. Okay, and an important note, as always, the museum itself is closed on our meeting night, so we don't have access to the Crazy Kitchen and all the other good exhibits. Okay, and if we go on, all right. So our next meeting is going to be Friday, September 5th. All right, but we can find that easily enough. It's always usually the first Friday. It's always the first Friday of the month. But the photo I want to show you is.
Oh no.
Go for it. There's Chris Tarrant, and that's his daughter Briar, who just got married on July 26th. So if you pass
She's been
Briar,
in meetings for years here.
That's right. If you pass,
But some of them run off the university, and this is what they catch. This is what happens.
so if you pass her our congratulations on her marriage. What's her hubby's name? What's her husband's name?
Craig Dent.
Craig Dent? All right. Okay, so congratulations to the both of them, and looking good. Hey, looking very nice. Now I have to ask, is Linda, are you here? Can somebody step out and ask Linda to come in, please? I told her I'd show her this photo. Can you go back to that, please? Can't run off, and then we'll scoot out in just a second here. Is she coming?
Linda certainly knows Briar.
She knows Briar, yes. Okay, Linda, there's the photo I was telling you about. Yeah, so there's Briar on her wedding day.
Is she still smiling?
All right, can we bring the lights up, please, Tim? All right, so if anybody has any questions for anybody, you can talk to us out in the lobby. We've got some drinks and that, and usual last line, I love you all, but now shove off. Yes, yes. Like a true sailor.